Got a chemistry exam coming up? Then you know balancing equations is an absolutely essential skill. Now, I know it can look pretty complicated, but today we're going to treat it like a simple puzzle that we can solve together. So, let's dive right in.
Come on, we've all been there, right? You're staring at this long string of letters and numbers, and you're just thinking, okay, where do I even start with this thing? It can feel a little intimidating, but I promise you, by the end of this, you are going to have a completely foolproof method.
All right, here's our challenge for today. Iron plus water gives us iron oxide and hydrogen. Now here's the thing. The biggest rule in chemistry is that you can't just create or destroy atoms in a reaction. But if you just glance at this, you can see we're breaking that rule. See? We start with one iron atom on the left, but somehow we end up with 3 on the right. That's our first big clue that something isn't right here.
Yeah, this might look like a bit of a mess right now, but there's a really simple solution. Instead of just randomly guessing and hoping for the best, we're going to use a super reliable step-by-step approach. It's called the table method, and it's going to bring perfect balance to this equation.
So, what exactly is the table method? Honestly, just think of it as our scoreboard. It's a simple little chart that lets us track every single atom on the left side, the reactants, and on the right side, the products. It's the perfect tool for the job because it's so clear, organized, and it just works every time.
Okay, so our very first step is just to get organized. We're going to build that table I was talking about, and this is going to be our guide for this whole process.
And building this table is super easy. Seriously. We just create 3 columns, one for the elements, one for the reactants on the left, and one for the products on the right. Then we just list our elements, so iron, hydrogen, and oxygen, and then we do a quick head count of the atoms on each side to see exactly where we're starting from.
And here it is, our starting table. You can immediately see the problem, right? Iron is way off, 1 versus 3, and so is oxygen, 1 versus 4. Hydrogen looks okay for now, but, we'll see if that lasts. This table makes our mission absolutely crystal clear.
All right, our table is all set up. So now the real puzzle solving begins. Let's get these atoms balanced.
So the first question you always want to ask yourself is this: where is the biggest gap? It's the best strategy, trust me. Always go after the element that has the largest imbalance first. And looking at our table, that's going to be either iron or oxygen.
You know what? Let's just start at the top with iron. On the left side, we've got 1 atom, and on the right, we've got 3. The math here is pretty simple, right? To make 1 equal 3, we've got to multiply it by 3. So that means we're going to put a big 3 in front of the iron on the left side of our equation. And boom, just like that, our table is updated. Iron is now totally balanced, 3 on both sides. That's our first little victory. 1 element down, 2 to go. Okay, let's move on to the next problem child, oxygen. We have 1 on the left and 4 on the right. So, to fix this, we're going to need to multiply the entire H2O molecule on the left by 4. That's how we'll get our 4 oxygen atoms.
Okay, let's check the updated table. Look at that! Oxygen is now balanced, 4 and 4. Perfect. But, wait a minute. By multiplying H2O by 4, we didn't just change the oxygen, did we? We also changed the hydrogen. We now have 4 times 2, which is 8 hydrogen atoms on the left, but we still only have 2 on the right. Uh-oh.
And this is a totally classic moment when you're balancing equations. You fix one thing, and it feels like it just messes up something else. You might be thinking, are you kidding me? What is this injustice? It can feel like 1 step forward, 2 steps back. But trust me, this is a completely normal part of the process. This visualizes that so-called injustice perfectly. Just a second ago, hydrogen was balanced and happy. But in the process of fixing oxygen, we've created a brand new problem. We've got 8 hydrogens on the left and still only 2 on the right. But hey, this is not a problem. This is actually a really easy fix. We just need one last move. To solve our new hydrogen problem, we just look at the right side of the equation. To turn those 2 hydrogen atoms into 8, all we have to do is multiply that H2 molecule by 4. And there it is. Take a second and look at that final table. Iron, 3 and 3. Hydrogen, 8 and 8. Oxygen, 4 and 4. Everything is perfectly balanced. That is that satisfying moment when all the puzzle pieces just click right into place.
So, our table confirms it. Every single atom is accounted for. And that means it is time for the grand reveal, the final, beautiful, balanced equation.
And there you have it.
3Fe plus 4H2O yields Fe3O4 plus 4H2. By adding those numbers, those coefficients, we've now satisfied that fundamental law of conservation of mass. Nothing was created, nothing was destroyed, every atom is perfectly accounted for. Mission accomplished.
So, the real takeaway here is this. By using this simple table method and always asking, where is the biggest gap, you've turned what looks like a confusing task into a clear, totally manageable process. And the only question